processes that lift air. And honestly, I'm a little bit excited to reteach this one again because my husband has been trying to get his private pilot's license, and so he's been studying meteorology actually, and he's been quizzing me on types of fog, so we'll get to that one later, and on processes that lift air. So this one he actually has to know, and I'm like, but wait a second, aren't you flying in Florida? You know, like last I checked, Florida was flat. I mean, okay, if you go into Central Florida, there might be a little bit of hill, but I mean, come on, right? It's not really going to have orthographic lifting in mild hilly areas or flat areas, but he still has to know this one. So there's a whole bunch of things that can lift air, and we're going to go over a few of them. Orthographic lifting is one of them, and basically it's just this. The air gets forced up and over the mountain range, okay? Because air can't really go through the mountain. I mean, as a geologist, I could argue it does, but not enough of the air, right? So the air goes up and over. And of course, as you go up, you what? You cool, you expand, you condense. Well, condense, clouds, precipitation, right? That's why all of the rain is here and none of the rain is here. That's why this is Napa Valley and this is Las Vegas. Another type of thing that lifts the air is fronts. Okay, so this is called frontal wedging. We don't get to front until much later on, but just trust me, this is a cold front, this is a warm front. They mix, warm air rises, right? I'm sure you're all surprised by that. Warm air rises. What happens when you rise? You expand, you cool, you condense. You condense, you have clouds, you have rain. Convergence. Okay, this happens in Florida. I mean, look at this picture. It's one of my favorite pictures of Florida. I love it. You can see Lake Okeechobee and nothing else. It's all just clouds, patches of clouds, right? It's great. Anyway, what's happening here is you get water coming from the Gulf, or not water, sorry, air coming from the Gulf, air coming from the Atlantic. So air this way, air has nowhere to go, so air goes up. What happens when you go up? You expand, you cool, you condense, you get clouds, you get precipitation. You starting to see a pattern here? And then you have localized convective lifting. Okay? My husband actually complains about this. He's like, this happens when we're landing and it's annoying because what are you landing on? A paved runway. And what's right next to that paved runway? Grass. Right? And the paved runway, we all know, we learned, I think, in the first chapter here, pavement is hotter than grass. And so that air heats up. And when air heats up, air does what? It rises. When air rises, what does it do? It expands, it cools, it condenses. When it condenses, it forms clouds. When it forms clouds, it precipitates. Right? So you're trying to land here, coming in for landing, air up, woo, da-bump, da-bump, da-bump. And then you eventually land. Right? See, he's caught in it. Whee! Now, Florida has the greatest frequency of afternoon storms, I believe, in the world. Why? Because we get convergence, air from the Gulf, air from the Atlantic up, and we get convective lifting, that localized convective lifting. So if you live, I don't know, in central-ish Florida, you get the most thunderstorms in the world. Huh. That might be the reason the hockey team is called the Bolts. Maybe, I don't know.